Hello, everyone. Hi, and welcome to our session today, the third session in our Concept from Concept to Creation AI-powered development series. My name is Moria, and together with me today is Jordan Dorr. We will both be presenting and moderating the sessions, and we will be with you in the chat through the entire session. So for those of you who are new to the Reactor, this series is part of the Reactor program. Microsoft Reactor is a community space for developers and for startups where you can actually have access to free learning, trainings, meetups, and all kinds of live and in-person events that offers you the opportunity to learn on different AI products and different technologies. Our program is located in 10 physical locations worldwide. But as I mentioned, since we are also offering online programs, you can actually access our events worldwide in different time zones. If you scan this QR code, you will be able to visit our website and see the list of upcoming events that we have around the world. If you scan this QR code, you will be able to register for our monthly newsletter. Our newsletter will give you the opportunity to receive a monthly email with all the upcoming events in your region, depending on where you're registered from. That's also for online and in-person events. Here you can also find a link to our YouTube channel, the Reactor YouTube channel, which is an opportunity to also mention that this session is recorded and it will be available for you on YouTube about 1 day to 36 hours after this session as part of the playlist that we created dedicated for this series. Before I go ahead, please, I continue. If you missed any of the QR code, don't worry, we will share them in the chat as well. I see Jordan already shared a few links, so all the resources will be available for you. Another platform I wanted to mention is the Microsoft Learn platform. For those of you who are new to it or not familiar with Microsoft Learn, it's basically a hub for developers that offer free learning opportunities, free trainings on different technical areas, depending on your level. From beginner to advanced, depending on your role. If you're a software engineer, if you're a data analyst, or anything else, you can really find different opportunities there to learn depending on your profile. So the AI Learning Hub actually gathers all the different resources that you have to learn around AI. This is again where you can scan the QR code and reach the AI Learning Hub. Back to today's session. So as I mentioned at the beginning, this is a series of 6 sessions that we started about 2 weeks ago. The idea here is to really provide you with different cases where you can see how we take AI and we actually create it from the beginning of the concept, the idea, until the creation, until we have actually we built either a product or we saw a robot in the first session. Really interesting series. I highly recommend you to register for the other sessions if you haven't done so, and also have to view the on-demand recordings of the previous 2 sessions. Before we start our session today, I wanted to highlight the code of conduct of Microsoft. Please take a minute to read the code of conduct of the Microsoft event. Basically, we ask you to keep, though it's an online event, to keep a friendly and respectful chat when you're using the comments box. So without further ado, I'm going to pass it over to Bill and Jose, our speakers for today. They are both Microsoft MVPs and a lot more. They will share more about their profiles and what are they going to talk about today. The session's topic is, of course, Azure AI services and Semantic Kernel. I will be here together with Jordan to monitor the chat. If you have any questions, please feel free to post them in the chat. So over to you, Bill and Jose. Everyone enjoy the session. Bye-bye.
Thank you, Maria. So I'll start. So you're probably thinking generative AI is incredible, and everything around it is amazing. But what if I told you that we, Bill and me, told you that there is something cooler than that, way more cooler, which is coding that in your favorite language, which on our own is .NET, C#, right? And integrating it into our apps. This with Semantic Kernel and Azure AI is possible.
Well, yes, and I think this will be a lot of fun and quite exciting. So let me first introduce Jose. So I'm absolutely delighted to be presenting with Jose, who is a developer community lead, a software architect at Swiss Life AG. He's passionate about technical communities. He founded the Barcelona.net developer and .NET Zurich developers, and he loves sharing his knowledge professionally as a technical writer, including a book that he's written on .NET 4.5. That's the old version of .NET. He's been recognized by Microsoft as an MVP for both AI and .NET, and been a technical trainer on .NET, UI and UX, and cloud for many years, and currently working on .NET, Gen AI, Azure AI, and machine learning. I've written this down because it's a long list. And a LinkedIn Learning instructor with 2 AI courses at the moment, which I would strongly recommend you take a look at. They're really good.
That's
Over
quite
to
a
you, Jose.
presentation, Bill. Thank you. That's quite a presentation. I think it's nice that this presentation brought us together as we did not know each other before. So what I can tell about Bill is he's super fun to work with, super curious on Gen AI and Semantic Kernel and Azure AI. He's also probably the person behind of a lot of technical material you are doing this that Moria presented. He has been authoring this material for quite a long time, helping Microsoft to get better at these topics. He's also LinkedIn Learning, so he deserves as well this tag that we did not put here. So did not have an animation, but that would be nice that it goes down. He's also an AI MVP for many years, and has been probably it's very known in the UK and international community and many conferences. So it's a pleasure to be here with you, Will.
Thank you, Jose. That's very kind of you. So a quick look at our agenda. If you can move on to the agenda slide, Jose.
Mm-hmm.
So we're going to look at semantic kernel and the basics of how to use it. Semantic kernel, it's an API that we can use to build these quite complex AI models. And just to be clear, this is not a no-code, low-code session. We are going to be using pro-code. We're going to focus on C#, although semantic kernel also works with Python and Java if you're coming from that background. We'll look at some of the concepts behind semantic kernel and also look at agents and particularly agentic AI, a fairly new term. It's really the sort of it's becoming big this year. It's sort of it's kind of new for 2024. We're talking about agents and agentic AI. So it's all very exciting. A lot of it's very new stuff. I think it's going to be a fun talk. So really looking forward to seeing some of these things in action.
All right. So let's see some code, right?
Absolutely. Let's go straight into the code. No more.
So
Well, there will be more slides, but we're going to go straight to some code.
okay, so can you see my screen? Yes, you can. Perfect.
Yeah, I think
So
might want to zoom a little bit the font
yes.
size.
Okay, so I will start with some basic semantic kernel, and I make it bigger. It's big enough this now, Bill.
I think that's probably good. Yeah.
Yep. So for everything to work, the first thing is you should add a semantic Microsoft.semantic kernel package.
That's a NuGet package, right?
Yeah, it's a package manager for .NET. They usually view programming .NET. And then you have to declare some variables, in Azure AI, we have Azure OpenAI or OpenAI, we have the model name or the model type, which usually is a deployment type for Azure AI. In this case, I put here GPT-4o, and then we have an endpoint when we are using Azure OpenAI, and then we have an API key, which you should never put in the code for security reasons.
No.
Right?
No, we'll see where we get these strings from in a few
Yes.
minutes. Yeah,
Bill
and
will show
this
you.
will support Azure OpenAI, but you can also go direct to OpenAI, can't you, if you have the right keys?
Yep.
If you have a model hosted. So it's not
Yes.
purely Azure OpenAI, but we're using Azure OpenAI because we love it, and that's where we've deployed our models.
Yes. And the first thing you have to do is create a kernel. You do that with a builder pattern, you create the builder, and then you add the Azure OpenAI chat completion, which comes from the Azure OpenAI, as the name implies. And then you add these variables that we retrieved before from the environment, and then you build it. And with that, you can do a prompt like, I would like to know what date it is and 5 significant things that happened on this day. Here we are doing some prompt execution settings, which is basically we are telling it that the tool call behavior, if it has tools, which it doesn't at the moment, is automatically. So Semantic Kernel automatically handles all the wiring for you. So when the model decides, I want to execute this tool, Semantic Kernel will do that for us. Very easy. And finally, we invoke the prompt that we define here. This prompt, we execute it, and we tell it, okay, use these settings. And finally, we print the result. As you can see, it's very straightforward, it's very simple. We can even execute that if the demos, god of demos. Oh, nice. No. One thing I should do is tell it that I want to execute the basic SK, which is the code I'm showing you now. And comment this one, which is the one other demo that Bill and me have prepared, which you will like it because it's lots of fun. And if we execute this and move that here, it will say, I'm sorry, but as an AI, I don't have real-time capability to determine the exact date, right? So it cannot do that. But we
This
will
is a
get to that.
limitation of these large language models, is they're so expensive to train, and so there'll be a version that GPT-4o will be one from a year ago, or its corpus of information stops at the point that they stop training it, and then we use that for a bit, these foundational models. So it doesn't know anything that's happened since the date that it was trained. And what time it is and what the date is an example of that.
Yeah, it's like they're living in the Groundhog Day, right? They
Exactly. Yeah.
will stay that day forever.
Yeah. As far as that's models
but
concerned.
We can change that, but that's something for the concepts. So before we move ahead, Bill, would you like to show us what can we deploy and get the other side, which is the Azure OpenAI model deployed?
Yeah, let's do that. So
Yes.
I want to share my screen. I am now sharing, I think, the right screen.
Moria, can you show Bill's screen?
Yes,
thank you. Yes.
Waiting for it. Oh, now it is. There it is.
Yeah, that's there. Yes. So I'm in the Azure portal here, and I've provisioned an Azure OpenAI resource called FlowSim AI. So if you've used Azure before, you'll know how to provision resources. Of course, most people do. It's very much the same as provisioning any other resource. Once I've done that, I can go to something called Azure Studio, Azure AI Studio. There are actually two versions of it. There's an older Azure OpenAI Studio, which they're still showing here, but there's a newer version of it, which I'm going to use. They give you a model catalog. So inside Azure OpenAI, there's actually this Azure AI service has a huge number of models that are available, including the ones from OpenAI, such as GPT-4, which we're using, GPT-4o, which is down here somewhere. There are also all these other models that come from there's GPT-4o. Phi, for example, is a much smaller model that Microsoft's built, which is smaller, faster, less expensive to run, because it's a smaller model that doesn't use as many compute resources, which is mainly GPUs in these data centers. and it's faster, and the costs are lower. So it depends what you're trying to do, which model you choose. GPT-4o, probably one of the more expensive ones. They also have GPT-4 mini, sort of smaller versions of that. There are other third parties. So the Meta have their own Llama model, and all its different versions with different sizes and different sizes of windows that you can use. And then there's Mistral as well, and as you go on, there's a number that have hosted on Hugging Face. So a wide range of models that you can choose from, and there's tools in here to do model benchmarks, so you can compare different models. You can build a chat interface and practice on it. Sorry, Jose, go ahead.
I think
there
we
we
are
go.
over. I think we are over 1,000, right?
Yeah, there's
1,000. It's incredible.
Yeah. So part of the skill is finding the right foundational model to build on top of, and that you do by experimentation. But in our case, we're going to use GPT-4, so we can deploy these models. So there's a step here where you say, I want to deploy a model, and you can also train your own models or fine tune the models as well. That's another topic entirely. But you can go through and choose what model you want to deploy. And once you've done a deployment, as part of that deployment process, you need to give it a name. So that's what we're using here. So in the code where it said deployment name, it was actually this column here, which is the name. Let me zoom this a little bit for you. This is the name of the deployment, which may or may not be the same as the model name. Sometimes it is. Here, for example, I've used GPT-3.5 Turbo, an older, slightly cheaper model to run, but actually still quite effective. But I've called it GPT-3.5, so that's what I would use in the code. And the other two bits of information we need, having deployed this model, to use it in code, is the API key and the resource endpoint. So for that, I need to go back to this FlowSim AI, Azure OpenAI deployment that resource that I deployed into Azure, and I go to keys and endpoint, and this is the endpoint here. So it's usually the name of the resource, and then .openai.azure.com. And then the keys here, if I click on this, you'll be able to see my keys. So I'm not going to click on
Don't do that.
No, I'm not going to do that. But it's a string of numbers and letters. It's basically a GUID without the hyphens, which you then also have to use. But we wouldn't recommend hard coding them. Put it in an environment variable, or keep it in key store or something like that. But so that's where you get that information anyway.
And definitely don't put them into your Git repository.
No, that's another common security mistake. Yeah, because if somebody can get this endpoint and the resource key, they can use your very expensive, potentially AI, OpenAI resource, or Azure AI resource. So we don't want to do that. Okay, back to you, Jose.
All right, Moria, can you show my screen? Beautiful. So we are done with the first demo. We have seen how we can deploy semantic kernel and use it in a very basic way. So let's move on to concepts. So you want to start with the first one?
Sure, yeah. So what have we got? AI orchestration. So what we can do, so this is an interesting discovery, was that when you build these foundational models like GPT-4, which are, as we say, very expensive to train, but it's a tool that we can use, but we'll see how we can sort of customize that. Even though we're not going to retrain the model, we're going to do things like change the prompts in various ways and provide additional information as part of the information that we provide to the the large language model in order to guide it to give it the answers that we want. And we can build various models around that, or build code around that, and then we can orchestrate them, so we can have multiple agents talking. One agent will go and get one bit of information, and then another agent will check it, or something like that. So you can build multiple agents into a sort of a one solution made out of multiple agents, and at that point you can even have one of the agents, one of the language models, is going to act as the orchestrator, and like the conductor of the orchestra, and all these different models work together. So that's one of the techniques that we're going to use. Another important technique is plugins. So Jose, if you want to talk about plugins.
Sure. Plugins are like this metaphor which I love, which is orchestra, where this guidance is provided by an orchestra director, and then we have agents or models, right? They have to play something, right? And this something is a plugin. It's a tool. We call it a function, tool, however we want, but at the end it's a plugin. It's something that extends the abilities of a model or agent, right? And it enables to play different tonalities, different music, extends the hands and the abilities in an extreme way, enabling them what before was not possible. Like we saw before we ask, hey, what's today's date? Simple model doesn't know. But for that, we have two types of plugins. Bill?
Yeah, and another thing we can do is, we, in the bit of code that Jose showed us a few minutes ago, there was a hard-coded system prompt, and those components, the prompts and the system prompts, you can sort of parameterize those, and it sometimes makes sense to put them into a file. I tend to use a JSON file. I think Jose, you in your example, you used a YAML file, but just a way of sort of managing those prompts, and that's another technique that we use. So that's another concept that we'll be using, and we'll see all of these as we work through the examples later.
All right. And then we have the native functions. So I like to think of prompt functions which are like prompt-based, as Bill explained, like air instruments, like we are humans, we breathe air, we speak, right? So it's kind of an air instrument like saxo. And the native functions, I like to think them as other kind of instruments. I put a piano because we touch it with our fingers. I like to think fingers digital. So it's kind of the metaphor I use. I use that in my course of semantic kernel, and I think it fits pretty well. So native function is everything we can code. We can attach that and let the model control that. Either it's getting the date of today, either it's connected to an API, either it's making a light blink or doing anything with, for example, Office 365. That's a native function. You can do anything you want.
Yes, and sometimes people look at this and they think, oh, large language models are wonderful, and they've wanted to solve everything with a large language model, but it's not always the best tool to use. And the way I like to think of it is, what would you expect a well-educated person to be able to answer as a question? If you ask them for the square root of 2, they might know. They might know the square root of 2. Ask them for the square root of 3,758, they won't know. They'll need something else, like a calculator or something like that. And it's the same with these with a lot of these plugins and
a precise one.
Sometimes we need to help the large language model with just regular code to do things. And
or how do we get a model to order us a pizza?
Yeah, exactly. We want to, so it does some action, then we need.
That's something we could build a session about.
Yeah.
Around it.
So this is the power of being able to code with the semantic kernel. We can build very sophisticated things just using regular programming techniques in addition to large language models. Okay, any more concepts that we need to cover?
All right. So yeah. So we have planners. So a planner, you want, or should I?
Yeah, go ahead.
Yeah, it provides a plan giving a goal. I mean, they were deprecated. They are still there in Semantic Kernel. We have the handlebars planners, but my personal feeling is they will come back because with planners there are a lot of things which are going on, like implementing self-learning into a large language model, and also to preview and do a plan and simulation of the actions to get to a certain. So it's kind of like reinforcement training, if people are familiar with that, which is we train a robot or entity or an AI to play a game like chess or Go or any other one, like for example, um, StarCraft, and they will learn to do that, or how to order a pizza and manage a portal to do so, right? So these things they will come back, but at the moment they are being deprecated because of the ability of the models to decide which tool to call next, but that has a limit.
Yeah, that's it's kind of it was a thing where you sort of do it manually, and now the model can do it. But as we get more sophisticated techniques, that's maybe something that we'll be coming back to. As a concept, it's there. You know, that's what the function calling is, which we'll look at in a minute. Is really it's deciding which function to call in which situation. As a concept. The next concept is personas. So that's where we say we want this model to behave in a certain way. And we typically do that through prompting and through the system prompt. And we'll see an example that Jose has built, which was a lot of fun, where we can give a model, a chatbot, a character or a persona. But that's
and
that's that's a key thing. You might say
and for
something like, "You are an expert in this," or "an expert on that," or "You answer in this style."
and
And
models are really really good at taking a character, and for that we have agents, which are the perfect place to put a persona in, right? An agent is an entity that can perform tasks in an autonomous way, use tools, means plugins, and have a personality, and as well the ability to do some kind of planning. In short, they can interact with the environment and do things in an autonomous way if we want them to. So for that we go to plugins. So without plugins, uh, the system doesn't have an idea. So like before, I ask the example code, hey, what day is today and what happened? And it have no idea. But if we give it a planning, it says, yeah, okay, give me the 3 facts that really work out in the past, right?
so let
So
me have a go at translating. So uh, it says the first one is the question is, what are the 5 most significant things that happened in the last 200 years? And the assistant says, I'm sorry, but I don't have the ability to get information from any time since. You have seen this response in English as well. If you're an English speaker, this is the sort of standard response of a large
yes,
language model when you ask it something that's recent. And now with the plugin, which can tell it what time it is, it's able to respond and give uh, useful historical information from its own knowledge, but it will have called the plugin to get what the current time is so that it can do
I
that
think I think
determination.
they are pretty good as historians, but we will see
Yeah,
that
yeah,
in the demo.
yeah.
So I'm going to
There's
show it.
plenty of material for the large language model to ingest on the historical data.
Yes.
It's not so good if you got some specialized field whether
So
or your own company where it's sort of secret information. Then obviously then there are other techniques like RAG, retrieval augmented generation, that you can use
yes.
to feed the model, and so you can build an agent that's specific to your business. That's what
Uh-huh.
co-pilots do in Microsoft 365. The co-pilots, or I think they're calling them agents now.
All right.
That's basically how they're working. Is they're augmenting that with contextual information before they send the request to the large language model. So
Cool.
what code have we got here, Jose?
Right now, what I just did, aside from uncommenting, it's I take the kernel, the generated kernel that we built, and I'm importing a plugin from a type. In this case, what date is it? So we will get the second one, and this is a plugin. So plugin is a simple class with a function. Well, the plugin is this one and has several kernel functions, and this one says in text, get the current UTC date. Just say it.
So the
This can,
only thing is there's a decoration of the. It's just it's not derived from any base class. It's just a simple method,
yeah.
and it's decorated with kernel function so that semantic kernel knows to call it. And the key is the description,
Mhm.
which you are about to explain, which is what the large language model is going to use to work out what the plugin
Mhm.
does, right?
Yes, and if we run it, so basically here we can put anything, return a string, and that's perfectly valid. And here, if I run it, and when I run, I move it here because we will see the result. Here are 5 significant events that happened on this day in history. In the last one, referendum, Sweden votes to join the EU. 85 eruption of one volcan. Vietnam War. Yep.
It's
And
pretty
World
interesting,
Day.
actually.
Fantastic.
I like this is a useful tool, actually. It's
Yep.
really interesting. So
And,
I can
and
think
this
of
is
a lot
super
of
simple.
useless. Yeah, that's like 20 lines of code, and we've got a really interesting model
Yes.
that can answer interesting questions. Yeah.
And it helps to the model to realize where are we living. And also, I want to reinforce this that a persona is affecting heavily how a system or a large language model reacts. For example, if we put the persona of Hulk with a blackout in Avenger City, what will happen? So clearly, Hulk will try to smash darkness, which may not be accurate, or Thor will try to restore light with Mjolnir. Probably it would not do good to hit um, a power plant with a lightning, right? And maybe the scientist attitude would be better for if it was, yeah, the arc reactor was a reality. But you get the point, right? So you put a personality in it and it will react to a problem, to a challenge, to a task with its personality.
So choose your persona carefully for good
Yes.
results. Yeah.
Yes,
Yeah.
exactly.
Yeah.
You
Yeah.
want to
So
elaborate?
yeah, sure. So planners. So what's actually happening with function calling is it's quite complicated. Behind the scenes, what it's doing is it's making a call to the when it makes a call to the large language model, it provides a list of functions that it has available. This is all going. You'd have to do this yourself if you weren't using semantic kernel, but semantic kernel is doing all this behind the scenes. And then the large language model comes back and says, okay, I want you to call these functions. And then your code calls the functions. This is again all happening inside semantic kernel, so we don't have to add any code to do this. And then it goes back to the large language model, and then you get a response back with the appropriate data incorporated. And that's how that example that we've just seen works. But all this is sort of happening automatically using function calling. And that's because these large language models have been trained, most of the larger ones now have been trained to perform function calling automatically. It's part of the training of the model is that they train it how to do this so that the large language model knows how to handle function calls. So that's basically how it works. But the beauty, as we say, is you don't have to deal with all this toing and froing. That's all taken care of by the semantic kernel API, which does that behind the scenes. But you could do it manually if you really wanted to.
I would. I like simplicity, so I rather not do that.
Yeah, I
All
don't want to
right.
learn how to.
Don't do that. Don't do that.
Don't do that.
All
Don't do
right.
that. Yeah.
Agents. So we mentioned before a bit what an agent is, so I will not jump too much on it. So agent is kind of a personality which can be funny, as the minion here. It can have a tool which can use like a banana, or maybe something like busy light, which we have one each, and you can figure out what the upcoming demo will be, which is fun. And yeah, and it has a planner, in this case provided by the model, that decides what tool or tools to use. And then with that you can go and do something a bit more fun, like a nice conversation. Like somebody says, hello, Bello, can I make your day more fun? I guess you have seen the movie Minions, or one of them, because there are many. I'm speaking with Bill on Semantic Kernel Agents. Oh, show something importante. Might throw a joke or two. Why do programs prefer darker mode? Because light attracts bugs. Okay, that was fun. Thanks. Somebody to say to the audience, say hello. And yeah, we keep going and going. And these things that you are seeing here, it's real text generated by the LLM that I copied and put it here. And yeah, let's see it live. So going to go here again. Going to program.
So while Jose is opening that, I'm going to start the same code on my computer.
Wait, I'm going first to
You
show
go
the
first.
basic.
Okay.
I'm going to show the basic one, right?
Okay. Oh, yeah.
Run it,
I'll
and
stand
we
by.
will. Oops. Okay. I think I will go straight to ours.
Don't forget that you
Because
commented some code earlier.
yes. Why is this? Oh yeah. Basically, this was not correct. Run it, and here. Hi, how are you today? It's big enough. Velo, muy bien, gracias. ¿Cómo estás, banana? Doing a talk. AI. Banana talk, interesante. Papoy, Azure AI. Want to send something to Bill? Ooh, banana papaya. Okay. And to the audience, let's make it a bit bigger. Bello audience, banana power. All right. So you can see AI can be also be fun. Cool. And just to be clear, this is simply using the same that you saw. I'm simply getting the path to a minion agent, which is defined here in YAML. And here I'm simply telling it that it's a cheerful, mischievous minion that he will use in mayonnaise. He will use mayonnaise and gibberish, say sometimes banana, react to the user inputs with enthusiasm. Well, basically, be a minion, right? Don't talk too long, be short, bring joy and humor and gibberish. So very accurate and very precise task, and very useless, but also useful if you want to have fun. Here we are adding the minion to the agents because I want to clean them. I'm doing some kind of old implementation here because there are several implementations that we can do, and this thing is completely experimental still since the first day, and still is experimental. And implement a while true for a chat loop, which I'm managing. And when I say banana or exit, it will say banana and break, and simply send invoke async with my message every single time. So, and then displaying it. It's very simple, right? And what builds the agent is new agent builder, which now we have several ways to do that, but this is one of them. Nothing more. All right. So, Agentic AI. What do you think about Agentic AI, Bill?
Yeah. So, what do I think about Agentic AI? Well, actually, I don't particularly care for the terminology. So, because there isn't actually such a word as agentic in English, but that's the word that people have used in all the papers about it. So we're stuck with it. So that's the correct term for what this is. And what it means is, unlike a tool like, say, GPT, that just you ask it a question and it gives you a response back, which is very exciting. Agentic AI is able to make decisions. It's able to actually do things. It can plan a strategy. It can even learn from its experience in pursuing some goal. And it really allows us to go beyond what these large language models can do by combining multiple agents. So Jose just built an agent that behaved like the minion, but we can have many specialist agents that do particular things, and they can all work together and be orchestrated. So it's like the players in an orchestra, a bit like teams of people as well, where everybody kind of works together.
It's exactly that.
Yeah, and that's we achieve more that way. So it can take a sequence of steps in response to a request, break it down into multiple steps and execute it, and then actually do something as well, and perform some action.
But I think importance here is usual usage versus agentic, right? Which is usually we use ChatGPT or any other one because we have plenty of them. We do a start, we write a prompt, it goes the prompt into the model, and then we get a finish. And if we have some problem, we have to realign it. Hey, ChatGPT or whatever, this was wrong. Please correct it, and then going
Yeah,
on and on and on, and that takes a
yeah,
lot of time sometimes.
yeah.
Even it saves time.
Frequently it comes up with the wrong answer, and it's very confident, and it's incorrect, and it hallucinates, and or it
Yes,
just doesn't really understand how to solve the problem.
and then we have the agentic workflow, which changes the game, right? So you can tell it or give it a task, write a starting draft, consider what areas need revision, and it can decide the things on its own. And basically what's happening is that, for example, this is called a critic pattern. You have a agent that is creating something, right? Or taking the task that you want, and you have a critic that will do the criticism and alignments before you were here on this finish and restarting everything, this feedback loop. And here, instead of you, you have an agent that does the work, so you don't have to. I like that. Do you, Will?
I do, and I've used this quite a bit. So when we're sort of generating documentation, for example, the first pass through a large language model might not be very accurate, but we can then put it through a second verification step where we give it another model that has been optimized, or it's been designed for specifically checking for grammatical errors and factual errors, and it'll use a plugin to go out to the internet and get information from the Wikipedia page or wherever it finds it, and check the facts. So on the occasions where the large language model has invented things that are not accurate, it can get them, and you get a much higher quality output than you would get with just using one large language model or one agent on its own. So highly effective and a real game changer. But I tell you what, Jose, we really should show one of these agents that actually does something. Shall we
Yes.
look at the demo for
Yes,
the?
but we will show a bit some papers because we
Okay,
are in AI like papers.
yeah.
There is this, I don't know, this one is pretty cool. You want to comment it a bit? Or
Okay,
should I?
so yeah, so more agents is all you need. Everything now ends up with is all you need, because the first Google paper was on transformer architectures, was attention is all you need. So now,
Exactly.
and then the Phi model, it was textbooks are all you need. So this is really, it's a succession actually of these papers and breakthroughs, where it turns out this is X is all you need. And there's this huge leap forward. It was a huge leap forward with transformers and attention, multiple attention heads. Another huge leap forward when quality of the corpus that you feed in, the training data. And now this is another huge leap, because we can use these imperfect large language models and build agents out of them and make them work together. This is quite a nice example here where you've got multiple agents, perhaps using different large language models, and you kind of do a voting system to improve the accuracy of the output.
Yes, in this case, it was a very, very simple, I would even call it stupid and the simplest paper ever that shows the power of agents. So there are papers that show a lot more. We will see in the next slide. But this one, you ask that to different agents to do a math operation. And at the end, you get some answer, one per agent. And then the agents vote, oh, this one is better. And then the one voted, it's a better response by like 15 to 20%. So accuracy is increasing just doing that by almost 20%, which is pretty cool, just using agents. But then if we go to coding, we have, it gets really, really better. This slide is from Andy and Jim. Put here the name, we have to code. And a serious shot on GPT 3.5, which is already old, is 48%. So really don't use GPT 3.5 for coding. And GPT-4, it gets a bit better, 67%. But what if we use agents, agentic AI? I'm not talking about one agent, but many. Wow, GPT 3.5 outperforms by far a larger and more advanced model, GPT-4. Isn't this incredible?
It is incredible. Yeah.
Yep, it is.
It is incredible.
And then if we apply the same technique to GPT-4, it gets better. It gets 97, but the difference is not that strong. It's curious, right? So
well, you're getting near the, near to
100.
it gets diminishing returns. It's getting harder and harder to get a further improvement because they're already pretty good.
Yeah, but would you pay like double the price for 2% more?
That is the downside of using multiple agents. Is there's multiple agents mean more cost
Exactly.
but if you need accuracy, it's worth it.
Exactly. So if we want to reinstate the importance of agents, a lot of people are talking about that, like Jensen Huang or Andrew Ng, and yeah, again, Andrew Ng and McKinsey and Bill Gates and yeah, more people. We could fill up a lot of pages about that, but basically the message is the next big thing is agents. And I am completely agree with that. And I'm not telling you, Andrew Ng, Jensen Huang is telling you. Bill is also on the same opinion.
It's quite funny. Bill Gates says there that it's the biggest revolution in computing since we went from typing commands to tapping on icons. We've kind of gone back to typing commands. So
I was talking. I was talking about you.
Speaking of which, have we got time? Is your server up and running? Are we able to do the?
It is. But first, we have one slide that it's your slide.
All right. Okay. Right. So let's just bear in mind, we must be cautious as well. So this is really moving things faster than we expected. A few years ago, most of the people in the field were predicting artificial general intelligence by about 30 to 40 years time. 35 years time was the sort of the average of the predictions. That has now come way down to a few years, and people are talking about sort of even this decade we could achieve artificial general intelligence, which has a lot of implications for certain existential risks and dangers. And there are some excellent books written about this. If you want to read books, Nick Bostrom has a book which is quite frightening about some of the scenarios. It's not the Terminator coming from the future. It's more somebody just gives some, in giving the goal for an AI system, you have to be a little bit careful that you don't ask it to do something. If it gets that clever, there are some dangers around that, and there are also ethical risks as well that we have to be aware of. So if we rely too much on these models, we might encapsulate biases and introduce unfairness. And there's a whole list of 6 or so of the AI responsible AI principles that Microsoft and others have set out. So we need to be aware of those and not get so carried away with this technology that something terrible happens. So we should be cautious as well.
I completely agree with that, but let's do the final demo, right?
Yeah,
and
let's
show that.
do that.
All right, so I'm going to
comment. So I'm going to start my client up. So I'm running the same client code, but this is slightly modified that Jose has been showing you.
Yes,
he's given me his code, and I'm running it here.
Just to be clear, what we have here is a BusyLight server that has a BusyLight hub, which I will take the breakpoint here because we were just trying it out a bit before the session to be ready, which is using SignalR to send an action.
Can you just hide your command window so we can see the code?
What? Oh.
Yeah. Oh, now everything gone now.
Okay, strange. Why was that there? Okay, so this is the hub. I'm not sure why was that shown, but yep. There's sending an action. It's doing a broadcast. And then I have here a plugin, which is a BusyLight controller, which comes from the code of Bill. So this was an idea that we decided to go ahead and do something fun. And then I have a plugin, what else, that will send a message to Bill or me, right? And it will do a connect, send Bronx and banana, and then
that's all using SignalR.
Exactly. So I think the best thing is we show it because now it's a plugin that will not only be doing something in local, but in the internet using a server that I have deployed in my computer, and then it acts as a host for the 2 agents, one which Bill is running and the other he is running, and we have here the busy lights. So I will send something to Bill. Hi, it's the same banana minion agent.
Still the minion, yeah.
Yes,
but the minion with a BusyLight plugin and SignalR.
And I tell him, hey, send banana to Bill, right? And this should be climbing. Hey, it's working. And I can send banana.
And you are in Switzerland and I'm in the United Kingdom, by the way. So we're not in the same office.
No.
We're a long way apart.
So I send you a banana, I send a correct and a banana. And now you can send something to me.
Now it's green, flashing green now. Yeah.
Okay. And it sounds, which...
So I can send... so I'll say send Jose a banana.
Also, this was inspired to me. Banana, flashing. I can put that.
And his is flashing. And of course, because it's a large language model, I can say send Jose. I don't have to say correct. I can say something like a yellow fruit probably will work. I'm guessing.
I'm not sure.
I don't know. Maybe. It says minion banana. You mean banana? I'll say yes, banana. Yes. Now, will it remember? As have you got history? Yes, it has history. So that's because that's another thing Semantic Kernel provides is history.
Yes.
So this is this is Agentic AI action getting. It's an agent that does something and makes lights flash on and off.
Yeah, it could be awesome a robot embodied. It's pretty cool. So you there is an example as well how to integrate with Office 365 and Microsoft Graph, which basically it can manipulate and handle your agenda, control your lights, or connect to your home. So you can do that, and you can even, if we put back that to open the door for you if you get what I mean.
Yeah. We've got some code anyway to share at the end. So if you want to
Yes,
have a try at doing this yourself,
we will share this.
but you have to have your own Azure OpenAI
we should
instance.
we should buy before we release the code. We should buy these some stocks of the busy light.
Yeah, we should buy stocks in this
Because
company.
it's
Yeah,
super
yeah.
easy. It's
It's
such a
supposed to be
nice
for
thing.
Teams to show whether you're busy on Teams, but
Yeah, but it has a
okay,
nice SDK that works
okay.
fantastically well with
Yeah.
.NET. Just saying. But
Let's wrap up with some conclusions.
yes,
This has been
so
I've enjoyed this so much.
it's been fun. So we have seen Semantic Kernel and a bit on Agentic AI. You,
Yes,
Bill?
yes, and we've seen how powerful it is. It's evolving fast. So a lot of these things we've shown, they weren't available. Like function calling wasn't available, say, last year. So everything's moving really fast. It's getting more and more powerful.
Yeah, and AI is getting better fast. So we got like 2 evolutions of models, or even 3 this year. We got the real-time API, which is not yet in Semantic Kernel, but we hope it will be soon. So our message for you is get to learn. And
And 2024 is going to be the year of agentic AI, I'm pretty sure. So, and as will 2025. So, start looking at this. If you're not already looking at building these sort of solutions, you should. It's going to be amazing what we can do with this technology, and it's moving so fast. We'll show some links right at the end for some
yes.
learning, MS Learning, and I think there's a link to your course as well,
Yes.
and the assessments that you can do as well. So we'll give you those links right at the end.
Our message to you is you should start learning now. And that said, I think it's been an absolute pleasure to speak to you. It's been really fun to collaborate with you, Will. And I hope that we have inspired you a bit in this fascinating topic, which is Agentic AI and Semantic Kernel.
Yeah, and thank you to our audience. Thank you all for joining the session. I hope you found it useful.
Thank you so much.
There's our links.
Oh, sorry.
No, just those are the links.
Oh,
yeah, we will share them. I think you have a resource page, right, for that. But here is Bill's contact, LinkedIn. You can follow him if you like his ideas in X as well. GitHub is pretty interesting. He has a SDK about the busy light, which is pretty cool. Here is mine, my LinkedIn X as well, and here is this GitHub is /Jose. And the resources for this is Semantic Kernel and Azure AI, but we will publish that in the resources and give them to Moria and Yarden, which is behind the scenes. And also the courses from that Bill has prepared is this learnmicrosoft.com semantic kernel overview. So he has been working there and also on this training path and certification, which is there. So thank you, Bill, for getting that done. And on my side, I have a course here on semantic kernel, which I did earlier this year. A lot of things have changed, but mostly it remains quite on the spot in a lot of things, except on the plugins, which are going to be deprecated, but they still work. And that again, I got to mention that one of the